this question says a certain radioactive isotope is a byproduct of some nuclear reactors. Due to an explosion, a nuclear reactor experiences a massive leak of this radioactive isotope. Fortunately, this isotope has a very short half-life of 14 days. Estimate the percentage of the original amount of this isotope released by the explosion that remains 9 days after the explosion. Now that's a lot of information to take in. So let's start with what formula we're going to use. So the formula that we're going to use for this problem is A of t equals A naught e to the kt. So this is the formula, and the parts of the formula we have the A naught. This is going to be our initial amount, our starting amount of this isotope. The K is going to be our growth or decay rate. And because we're talking about the isotope having a half-life and how much of it remains after 9 days, this is going to be a decay rate, and this value will come out to be negative. So because it has a half-life, it's decaying instead of growing, and will have a negative value of K. Then we have our T, which is in time, and looking at our problem, we're dealing in days. So T is time in days. And then our A of t is our ending amount of this isotope. A of t is the amount after t days. Okay, so now that I think you're a little bit more comfortable with the formula, this question really needs to be done in two parts. This information about having a half-life of 14 days is going to help us find this K value, the decay rate. And then after we find that decay rate, then we're going to be able to answer this question that's being asked. So we're going to ignore this information about 9 days after the explosion until we figured out the value of K. So it says we have a half-life of 14 days. Now I think it's pretty obvious that 14 days is referring to the time. But this half-life is the amount of time it takes to decay to half of what you start with. So this is really telling us the relationship between the starting amount of the isotope and the ending amount of the isotope. So this is saying that it takes 14 days to decay to half of what you started with. So for example, if you started with, say 100 of the isotope, then after 14 days, you would then have 50 left. So it's telling you that relationship between the initial amount and the ending amount. So that is going to be A equals 1/2 of A naught, half of what we started for half-life. So we're going to take our formula, A of t equals A naught e to the kt, and substitute these two pieces of information into that formula. Having a half-life means that my A of t is going to be half of my starting amount and a time of 14 days. Now we're going to be able to solve for that value of K, the decay rate. We're going to solve by dividing by A naught on both sides. That gives me 1/2 on the left, and e to the 14k on the right. Then I'll take the log of both sides to solve this exponential equation. I can use the power rule to bring that 14k out front. Natural log of e is 1. So that gives me 14k. I'll divide both sides by 14, and I get k equals natural log 1/2 over 14. So now I have my decay rate. And now I'm going to be able to answer this question that they ask. Estimate the percentage of the original amount released that remains 9 days after the explosion. So my model started off being A of t equals A naught e to the kt. And now that I've figured out that now that I've figured out the decay rate, I can substitute that in. I could put that in my calculator right now, but I don't want to round too soon. So I'm going to leave it in that messy symbols so that it's exact and not rounded. So we want to know how much is remaining 9 days after the explosion. So we're going to substitute a 9 in for t. So A of 9 equals A naught e to the natural log 1/2 over 14 times 9. We're going to put that in the calculator. That's e. I'm going to put the 9 in front. E to the 9 times natural log. I will type 0.5 instead of 1/2. Close parentheses for the log and divide by 14. So that's going to give me A of 9 equals A naught times 0.64. And if we go back and read this question one more time, it says we want to write our answer as a percentage, and we want to round to the nearest whole number for our percentage. So we got 0.64. We'll move that decimal place over 2 to turn it to a percentage, and that's 64%. 64% will remain 9 days after the explosion.